We are eliminating the parameter. So to do that, we are going to take this second equation and we're going to solve it for t. So t will be equal to y plus, well, 2t will equal y plus 1, right? So t will equal y plus 1 divided by 2. So everyone see how I did that by adding the 1 to both sides, dividing by the 2, so that my equation, my second equation for y is in terms of like t equals. Okay, that allows us to substitute it into the other one. Now, why did I choose to solve for t in the y equation and not in the x equation? Yeah, we have lots of static. Okay. So because I didn't want to worry about having a square root, right? And like remembering you have to have a plus or minus with the square root and whatever else, that just seemed like it was more complicated. So I tried to keep it easier by solving the linear equation for t instead of the quadratic. Okay, so I've got the other equation, x equals, and I'm going to put y plus 1 over 2 in there. And now I want to simplify this because I think it could look better, right? So let's go ahead and move the 3 to the other side. And then we have y plus 1 squared over 4, because that whole thing is squared. So what is this starting to look like? Like some sort of conic section, right? We've got x, we've got y squared, we've got a number dividing, which we may or may not want it dividing if we were to put this in a form we're used to. What kind of conic section has one of our variables squared and the other one's not? Perfect, parabola. So this is likely a parabola. I'm going to get rid of that fraction by just multiplying both sides by 4. So that will give me, I extended my page way too far. So 4 times x plus 3. I wouldn't distribute the 4 through though, because if you remember your conic sections, you would remember that that 4 actually means something in the graph, right? I don't think this says we have to graph it, does it? It just says eliminate the parameter, correct? I think I threw it on there just for reference in case we wanted to try to remember how this conic section would look. I don't know if you care. So when y is squared but x is not squared, what direction will our parabola go? Do you remember this? Just for fun, this is a fun little review. Perfect. Okay, so with the parabola, we have a focus and a directrix. The vertex of our parabola will be at -3 because that's the opposite of the number with x, and -1 because that's the opposite of the number with y. And then this 4 right here tells us that the distance, I don't remember what the word is called, but the distance to the focus and directrix would be 1. And that's because the formula we learned for parabolas is 4 times a, or 4 times whatever letter we were using for that distance. And then that 4a number, so in this case the 4 right there, is the length across the parabola at the focus. And remember that was the length of the lattice rectum. So just for fun, I'm reviewing. Am I spelling it wrong? I don't know what it's spelled. Something like that. So if we wanted to graph this, I'm just going to throw, we don't have to graph it. I am graphing it just simply to help solidify this in your brain and to make sure you relate it to what we've done previously. So -3, -1 is our vertex. Our focus would be 1 to the right. Our directrix would be 1 to the left. And then the length of the lattice rectum is 4, so that would be here, up 2 and down 2 And so our parabola is here. Ah, how do we know it? It's that number. It's that number before we divided the 4 out. So the formula we learned way back when was like y minus k squared equals 4. I think it's a. It might have been p. I don't remember now. X minus h. This was the formula we learned. So for A is the distance to the focus and directrix, and 4 times A, or just that whole number there, is the length of the lattice rectum. Does that sound familiar? Do you guys remember this? So, how many of you have this problem from when we did it um, on Wednesday? This goes along with example 1 from Wednesday. It's the same one, but we graphed the parametric equations in that case. And when we graphed the parametric equations, t had to be greater than or equal to -2, which meant that our graph actually started at a point here. What was it? It was at -2, -5. 1, 2, 3, 4, 5. I didn't sketch this very well, as usual. So rather than our parabola going forever that way. So Adrian mentioned earlier, how do we know the orientation if we get rid of the parameter? How do we also, the other question is, how do we not only know the orientation, but how do we know where it kind of starts and ends, right? So we're going to do that through more or less a domain and range, which typically domain and range are reserved for functions, but in this case, it's the best way we have to describe our x and y values. If you don't want to call them domain and range, that's fine. Just so our x values would go from you could do it as interval notation, but I'm going to do it in set notation. It feels like it would be better. So the smallest that x could be would be 1, 2, 3, 4, but not including 4. So -4 is less than x, which is less than infinity. Right? Did I count that wrong? Oh, it's actually -3 because I was thinking that the directrix is an asymptote, and it is not an asymptote. It is just a definition of what a parabola is, but it's not actually, the graph is not getting closer and closer to the directrix. The closest the graph goes to the directrix is that distance 1 away from it. So, oops, I'm glad I'm looking at my notes for that. So it does go clear to that -3 at that point, correct? Because that's the vertex. And then it's going to go to infinity this direction. Well, then our y value, the lowest the y value will go is here at this point right here, 1, 2, 3, 4, 5. So -5 is less than or equal to y is less than infinity. Oh, I don't need that parenthesis at the end. I was mixing set notation with. So this helps define the fact that our graph ends right here, because this formula we just created, this equation for a parabola, does not tell us without the parameter that our graph is not going to go beyond that point. Does that make sense?